Welcome to S Chemistry, and I also welcome the lecture series, the Nobel Prize in Chemistry. So I will be delivering lecture on the topic the Nobel Prize in Chemistry 2023, which is entitled as the discovery and synthesis of quantum dots, presented by Dr. Suhas Gauri, Assistant Professor in the Department of Chemistry, Sundarrao Solanke Mahavidyalaya, Mazilgaon, Beed. Here is the outline. First, introduction and background of quantum size effect. Then, Nobel Prize winner for the discovery and synthesis of quantum dots, followed by commercial application and the futuristic application. Let's start with introduction. First, I will introduce what is meant by Nobel Prize. So, the Nobel Prize in Chemistry is one of the six prizes established by Alfred Nobel in 1895. So, the six international prizes are awarded annually for outstanding work in the subject such as physiology or medicine, physics, chemistry, literature, economics, and the promotion of peace. The Nobel Prizes, first awarded in 1901. Alfred Nobel was a he is a picture as Alfred Nobel. So he was a Swedish chemist and engineer. So he invented dynamite in 1866. Ginite and the other high explosive, making a large fortune, which enabled him to endow the prize that bears his name. As stated in his will, the prizes was to be awarded to the person who shall have made the most important chemical discovery or improvement in the field. So, this award is generally awarded by the Royal Swedish Academy of Sciences at Stockholm, which is located in Sweden. The prize is considered the most prestigious in chemistry. So, the prize is awarded annually on 10th December each year. So, which is anniversary of death anniversary of Alfred Nobel's, and has become so far awarded 115 times to 194 Nobel Prizes laureate between 1901 to 2023. So let's start what is meant by quantum dots. So as you can see in this given figure, so these are the various different sizes of quantum dots. So these are five different shapes, different color is made up of the same material. So in same material, large particle have a red color and a smaller particle have a blue color. Is at its core the a quantum mechanical effect. So this is due to quantum mechanical effect. So this has a lesser size due to the size difference. This is smaller and this is bigger. That's why it has a different color property. That is a physical property. So the particle in a box concept of quantum mechanics. So this is a kind of a prediction. So the quantum mechanical mechanics predicts that if you take an electron and put it into a small space, the electron wave function gets compressed, and the smaller you make the space, in this case the particle, is the larger the energy of the electron. So as you can see, the space is smaller, so your this amplitude is the larger. So larger the energy of the electron, the smaller the space. So this always follows in quantum mechanics. So if you can store more energy in an electron, it can also give more energy to a photon. So your light, imitation of light is nothing but, or reflection of light is nothing but, so a kind of photon effect. So lesser, if you can store more energy in the electron, it can also give a more energy to a photon. So that is the basic concept of quantum mechanics. So let's see about the background of quantum dots. So quantum phenomena in the nano world were just a prediction. So who's made this prediction? That is, the name of scientist is Herbert Franchlight. Franchlight. So he is the so in 1937, the physicist Herbert Franchlight had already predicted that a nanoparticle would not behave like other particles. So he explored the theoretical consequence of the famous Schrodinger equation, which shows that when particles become extremely small, there is a less space for the material electrons. So as we know, in each particle there will be proton and electron. So as you compress the size of your particle, that is in nanoscale, so your electron will be having a less space. So because of that, you will be having a different property. So that he's explored this idea using the theoretical consequence of a famous Schrodinger wave equation. So using mathematical tools, he succeeded in predicting the numerous size dependent quantum effect. So let's get introduced about the quantum dots. So you can see in this picture the size of the nano. If you compare the size of the quantum dots is a crystal. So a quantum dot is a crystal that often consists of just a few thousands atoms. So in terms of size, it has the same relationship to a football, and as a football has to the size of the earth. So you can think about the how small this quantum dots crystals is. So let's see who got the Nobel Prize in Chemistry 2023. So the Nobel Prize winner in Chemistry 2023 for the discovery and the synthesis of quantum dots. So first person or scientist, his name is Alexei Ekimov. So he is the scientist from which is formerly chief scientist at nanocrystals technology included in New York City, which is based in USA, United States of America. The second person who received the Nobel Prize in the chemistry 2023, that is Louis E. Bruce. So he is working as a professor at Columbia University, which is located in New York, United States of America. The third person is Munagi G. Bawendi. So he is also professor at Massachusetts Institute of Technology, Cambridge, uh, in United States of America. So the Nobel Prize in Chemistry 2023 awarded to these three scientists. They owe the Nobel Prize for the discovery and synthesis of quantum dots. So Alexa and Ikimo and Louis E. Bruce discovered quantum dots. So these two people discovered the quantum dots, and Munagi Vivendi synthesized of good quality and quantity of quantum dots. So in 1993, Munagi Vivendi revolutionized the chemical production of quantum dots, so resulting in most perfect particles. So this high quality was necessary for them to be utilized in application. So the mystery of colored glass, which is given initially by Alexei Ekimov. So as you can see in this figure, so he has synthesized this glass which has a different color. So he synthesized a systematically produced glass that was tinted with copper chloride. So he heated the molten glass to a range of temperature between 500 degrees Celsius and 700 degrees Celsius, varying the heating time from 1 hour to 96 hours. So he used only glass. So he was working in that field in glass and to production of glass as well as tinted glass or colored glass. For the color, so he used this metal source, that is metal salt is copper chloride. So what he did, so he heated the molten glass, normal glass which is colorless glass, to a range of temperature between 500 degrees Celsius to 700 degrees Celsius. So between this range, he kept that glass for this temperature for number of different hours, like 1 hour to 96 hours. Then once the glass had colded and hardened, and he x-rayed it. So what he observed in x-ray, the scattered ray revealed the formation of tiny copper chloride crystal within glass, which is influenced by manufacturing process ranging from 2 nanometer to 30 nanometers in size. So using X-ray, he checked because with the same chloride, that is salt, he observed a different color. So he was curious about how the process is happening and how the by varying different temperature we are getting different color. So the main he characterized by X-ray. So main observation he found that so the crystal copper chloride crystals has a different dimension, different size, particle size. So that is range from 2 nanometer to 30 nanometer in size. So here I have given observations. What he observed, the size of the glass particles significantly impacts its light absorption, with large particles absorbing light like copper chloride, while a smaller particle absorbed blood bluer light. I will give a brief introduction about the name of Ikimo Alexei. So, Ikimo studied semiconductor, important component in microelectronics. So, in this field, optical method are used as a diagnostic tools for assessing the quality of semiconducting material. So in 1981, Alexei Ikimo have discovered quantum dots at St. Petersburg Vavilov State Optical Institute. The Alexei Ikimo succeeded in creating size-dependent quantum effect in colored glass. The color came from a nanoparticle of copper chloride, and Ikimo demonstrated that the particle size affect the color of the glass via quantum effect. So he had observed this quantum effect, that is a size dependent. Now we will see what Louis E. Bruce contribution in this field. So the strange property of particles are quantum effects. So that was his statement. That is a strange property means a color dependent property is that is coming from a particle, and that particles are a quantum effect. So here is in this picture the quantum effect arise when the particle shrinks. So as you go down or reduce the particle size, you will be having a different quantum effect. So when particles are just few nanometers in a diameter, the space available to electrons shrinks. So this effect the particle's optical property. So as the electron has a less space to move inside this available space, so that's why their optical property changes. So the smaller the nanoparticle, less space for the electron wave, and the larger the nanoparticle, more space for the electron wave. So if your wave is larger, then your energy will be lesser. So given this constraint, you will be having more space, so your energy will get reduced for a single electron. That's why you will having higher wavelength. And for this blue color, you will be having a shorter wavelength. So that's how your quantum effect uh, is arising from the particle size. So what he did, the quantum dots absorbs a light. So when and then emit it at another wavelength. So its color depends on the size of the particle. So he took a same lamp, that is a purple lamp, bluish lamp, and he observed that if you shine with the same lamp but with a different particle size, you will be getting the different color of the uh, different photon. Each particle different size, you will be emits a different color. So some particle, a smaller particle will deliver bluish color light, whereas bigger particle size will deliver the red color light. Now let's see the experimental contribution of Louis E. Bruce for the field of quantum dots. So as you can see in this figure, the quantum dots absorb a light. So this light is shown here purple color, but actually he used a blue color light, that is UV light, because it has high in energy. So after uh, Alexei Ikimov published his work in 1981, so Louis Bruce was the first scientist who published his studies in the world to prove the size dependent quantum effect in particle floating freely in fluid. So the quantum effect he brought into the colloidal state of matter. So Ikemo did in glass phase or in solid state, but Louis E. Bruce he delivered this quantum effect in liquid state, that is in fluid, in colloidal state. So what he did, he has taken a 5 stock solution of different particle size. So here a red color particle size is bigger than this blue color particle size. So as you can see, uh, for larger particle size, you will be having a red color light is as a emitting light, and for a small particle size, you will be having a blue color light emitting. So that was his observation. So let's see what Monagi Pavendi did in this field. So he has given the synthesis part of quantum dots. So he has given the how to produce quantum dots like qualitatively and quantitatively. So he invented indigenous chemical method for synthesis of quantum dots, makes in a solution with exclusive control on size and the surface. So what he did, the procedure is given, schematic procedure in given this figure. So he has taken a three neck round bottom flask. So one neck he fixed the thermometer. In second neck he injected the stabilizing gas, that is inert gas or any reactive gas depending on the which kind of quantum dots you want to prepare. And third neck of RB was used for the injection of uh, chemical compounds. So Bevendi injected a substance that can form cadmium selenide into hot solvent. So the given solvent is in hot condition and he injected that cadmium selenide into this hot solvent using the syringe. So the volume was enough to saturate the solvent around the needles. So second step, what he did, so a small crystal of cadmium selenide immediately formed, but because of the injection cooled solvent, the crystal stopped forming. So he injected this cadmium selenide into this hot water, but after the injection, this whole solvent got uh, into the cold form. So due to this injection, so what he did, just to increase the size of the crystals, he started heating at the bottom. So when Bevendi increased the temperature of the solvent, the crystal once again started to grow. So the second step was the nucleation step, and third step is the from nucleation to growing state. So due to this heating temperature, your particle size starting increasing with respect to time. So as your time increases, your temperature keeping as a constant, so your particle size is growing. So the longer this continue, the larger the crystal will become. So if you keep this heating process for a longer time, your this crystal will become in larger size as you grow on with time. We are moving to the next slide, that is commercial application. So let's start the commercial application of quantum dots. So quantum dots have many fascinating and unusual properties. Importantly, they have a different color depending on their size. So that's why quantum dots now illuminate computer monitor as well as television screen based on QLED technology. So they are also add nuance to the light of some LED lamps, and biochemist and doctor use them to map the biological tissues. So here QLED means quantum dot light emitting diode technology. So that is generally used for the screen, television screens or mobile screen. Nowadays, it is based on OLED, that is organic light emitting diodes. In future, it will shift to the QLED, that is quantum dot light emitting diode. So scientists also used as a imaging technique in the field of biochemistry or nanomedicines. So because the size of the quantum dots in a nanometer, so that's why if you attach this quantum dot to the particular nano carrier, then it will act as a nano light when your drug is carrying throughout your organs in the body or tissues. So that's why this technology can be used to map the cells as well as organs. Moreover, it has application to track tumor tissues in the bodies. Now, coming to the uh, futuristic application part of quantum dots. So, it will be having application in the field of flexible electronics. Nowadays, mobile phones are coming as a very uh, tiny, small device, but in near future it will come as a completely flexible electronics. So your mobile phone can be completely bent as same as fiber plastic. So it is also has application in sensor, that is tiny sensor, that this quantum dot also can be used in to make a thinner solar cell. So solar cell as this quantum dot can also be conducting, and this is related to the photon. That's why this technology can be used to make solar cell uh, thinner. So it also has application in encrypted quantum communication. So from one, if you want to carry data from one end to another end, so in between you have to, for security purpose, you have to make encryption. So this quantum dot also has application in encrypted quantum communication. So here we came to end of this lecture, and these are the references for the images, and for the data or articles I have followed. So student can refer this. Mm, I hope this lecture is useful for student, and I thank you for watching. I hope this presentation has given you much clearer understanding of quantum dots. See you in next lecture. Till then, happy learning.